Right, we're still looking at area between curves, or area of regions that are defined by curves. In the last example, we had a region that started at a natural point of intersection and ended at an arbitrary vertical line of x equals 3. Here, we're going to look at a situation where both of the limits of integration are going to be naturally occurring. So if we graph y equals x squared, we all know what that looks like. Got our parabola. And then the line y equals 2x goes through 0, 0, and 1, 2, and 2, 4. So the area we're looking at is fairly small here. Right, that's the point 2, 4. So looking at something with a not very big area. So I'm expecting a result of somewhere in the neighborhood of 1, maybe 2, I don't know. Setup is the same as last time. We're going to do the integral from where the region starts, which is at 0, to where the region ends as far as an x value, that's 2. And it's going to be the top curve, which here is the 2x, the straight line, minus the bottom curve, which is x squared. dx represents the width of the rectangle. Okay, now what happens if you put these in the wrong order? If you do the bottom curve minus the top curve, you just end up, assuming you do everything else right, you just end up with the correct answer but with a negative sign in front of it. Our integral is x squared minus x cubed over 3 from 0 to 2. And that'll be what? X squared, that's going to be 4, and then minus 8/3, which is 4/3. I said I was expecting something between maybe 1 and 2. That's exactly what I got, or somewhere around 1 or 2. Definitely a very small result. So I'm happy with that. Let's look at another one here. Got y equals x squared. We know what that looks like. And then y equals 4x minus x squared. If you don't know what it looks like, you can always graph it in the calculator, and that'll give you a real good sense of what it looks like. Sorry about my shadow today. I think they're worse than normal. It's going to be a parabola with x-intercepts at 0 and 4 and its vertex up at 2, 4. So, very similar to the last one. Unfortunately similar. I should have picked two that were a little different. We've got our intersections at 0 and 2 again. So integral from 0 to 2. And the top function this time is the upside down one, the 4x minus x squared minus the bottom one, which is just x squared. So there's our f, there's our g subtracted dx. The actual integrate, well, simplify first, right? This is the integral from 0 to 2 of 4x minus 2x squared dx. The actual integration is simple. We get 2x minus 2x cubed over 3 from 0 to 2. And that gives us, sorry, that's 2x squared. My bad. Right. Increase the exponent to 2, divide by 2. That gives us the 2 out in front. So 2 times x squared there. We plug a 2 in, we'll get 8 minus 16 over 3. 8 is 24 over 3, so we subtract those and we will get 8/3, which I did not do an approximation of this. It's very similar to the previous one, except that the top curve isn't straight. The top curve is bulged out. We end up getting an area of exactly twice what we got last time. So I definitely believe that. All right, see you next time.